So as we wrap this up, we started with the trig inverses. We learned how to plug and chug those. The proofs for those are still coming. All right, but now we're going to learn how to differentiate polynomial inverses, or how to work with that. Okay, so just let's talk about how do we define an inverse. If one function is the inverse of the other, tell me what tests have to be passed. VLT and HLT. Okay, so that has to be true. So if we know that they're given, we know the VLT and the HLT are both passed. And we know that if A is on f of x, so A is a point on f of x, then we're working with the point A comma f of A. A is the x coordinate, f of A is the y coordinate. If these are inverses, then we know on the g function, we've got b comma g of b. Because they are inverses, what can you say about the relationships of those x and y coordinates? The value of A has to be the same as what? G of B. Yes, inverses, these two have to be the same. What else has to be the same? The other way. So we can conclude that A has to be equal to G of B, and B has to be equal to G of A. Understanding that those x and y coordinate terms switch places is going to be really important to doing a derivative. Oh yeah, F, sorry. Thank you. There we go. All right. Okay, so if you have something that passes the VLT and the HLT, how do you find the derivative of an inverse function? And the answer is that you don't. You get rid of the inverse function instead of finding the derivative. So let me show you how to do that. Let's start with, we're going to go through the development of it. Let's start with g of x being defined as being equal to f inverse of x. I don't want to find the derivative of an inverse. I want to get rid of the inverse. So let's think about mathematically how we've learned in your course of history of math how to get rid of inverses. The first inverse you learned was addition and subtraction. So if you wanted to get rid of a 4, what did you do? You subtracted 4. All right, and then you learned multiplication, whose inverse is division. So if you wanted to get rid of a 4 that was multiplied, what did you do? You divide. Okay, and then you learned how to square things, and if you wanted to get rid of a square, what did you do? Square root. And then when you cubed something, you learned how to do the cube root. And then when you logged something, you learned how to do the log and the natural log are not inverses of each other. You learn to log something, and then how do you undo a log? And it depends, not necessarily e, some exponential. If it was a natural log, you would do e, but if it was log base 2, then you would exponentiate with 2. If it was log base 5, you'd exponentiate with 5. All right, so when we want to get rid of an inverse, we do the opposite, which is the inverse. What's the inverse of f inverse? F. F is the inverse of f inverse, those two things. So I'm going to get rid of f inverse. Some people say divide. And I'm like, no. We don't divide an inverse. That's not how it works. The way you get rid of an inverse is by applying an f to it. So f applied around the f inverse. But if you do it to one side, you have to do the exact same thing to the other. So I also have to apply an f around the other side as well. You got to keep your math legal. How does that clean up the right side? What do f and f inverse do to each other? Right, and so I'm left with x. And then on the other side, I have f of g of x. Now I can do a derivative. because I have a derivative rule that will help me with my left side. What derivative rule do I have that helps me with the left? Chain, okay? The chain rule. The chain rule says deal with which part of it first? The outside. Doing what with the inside? Nothing. Then deal with the inside. All right, let's deal with the outside first. What's the derivative of f? F prime. What do I do to the inside? Nothing. And then what do I do to the inside? G prime. What do I am doing to the inside of that? Nothing. And then what do I do to the inside of it? Times the chain rule again, which is 1. And then on the other side, what do I have as the derivative of x? 1. And I am trying to find the derivative of g. Do you see the symbol for the derivative of g somewhere? Right here? So just get that alone. If you're trying to find it, get it by itself. So what do I do legally to get it alone? Then now I can divide. Why am I allowed to divide now and I wasn't allowed to divide before? Because this is a multiplication symbol. And a multiplication symbol means you're allowed to divide to reverse it. So then I get g prime by itself. And I get 1 divided by f prime of g of x. In other words, an inverse derivative, by definition, is the reciprocal of the regular derivative. An inverse derivative is simply the reciprocal of the regular derivative. Not f of x, f prime. Mm-hmm.
Oh, if you were finding the derivative.
Yep, let me show you here. It works great. This little box is awesome at helping us think of it, okay? All right.
F of x, would it be
F of, yeah.
1 over f prime of just x?
Yeah. All right. So let's see. Put an f here and an f inverse here. And I want you to put point here and slope here. All right, this is going to help you organize your work on this, finding derivatives. Okay, you always start, if these are your like 4 boxes, you're going to start in like what we would call, position 1, kind of like a quadrant. You're going to start there. You have to know the point. Okay, you have to start with a given point. And the point you'll be given is B, comma, A. In the problem, you will be given the point. If you know B, comma, A, then what's the point I can put under the F column? A, comma, B. Okay, that is true. Hi. All right, once I have A, comma, B under the F column, I can find the derivative F prime of A. I can figure that out. Once I know that, then the final box is simply the reciprocal of the derivative. So 1 over F prime of A. And then you have the slope that you need for the derivative, for the inverse, excuse me. So start here. Work your way around and you will end up where you want to be. So the question is always, here's the inverse function and here's the point, find the derivative of the inverse at that point. You can't go directly from the point to the derivative. You've got to go through the original function and figure out the original function and then come back. So we're going to practice this. By the way, here are a couple rules. Has to be continuous. Has to be differentiable. We already know it has to pass the VLT and the HLT. And the other rule is it can never be horizontal. Okay, it can never be horizontal because if it was horizontal, what would the slope be? 0. And if we were trying to find the inverse of that, what would the reciprocal of 0 be? It would be 1 over 0, which is a problem. So that's the only other reasons. You can't have any horizontal pieces in what you're looking at. Yeah?
Does that mean that, like, didn't we talk about, like, the graph of tangent? It's like a horizontal, so does that not work?
The graph of tangent, are you talking about inverse tangent or regular tangent? Regular tangent has a horizontal piece at at the origin. And so we can do anywhere on the tangent except at the origin. So we can't ask you about the origin. Okay, so you just exclude it. Same as sine and cosine. Remember how we had to restrict sine and cosine to a smaller section? We just can't include the tops and the bottoms where you just open circle. We're not including that. The domain doesn't include it.
Doesn't the horizontal line just fail the HLT anyway?
Yeah, so no. Horizontal line doesn't fail it. Horizontal line would only fail if that horizontal line hit something else at the same time. That's what the horizontal line test is, if it hit it more than once.
Oh, right.
Okay. All right, here we go. Here's our function. We're told that the function is the inverse of a different function. And then we're asked to find the derivative of g. And g is the one that's the inverse, right? We're asked to find this. This is what we're trying to find. And g, by definition, is an inverse function. You don't actually have to find the inverse function to be able to find the derivative. If you just set yourself up here, and remember that this is the f, and this is the g, where g is the inverse, you should be fine. You're going to start with the point. The point I'm given is the g point, 2, 1. So since they're inverses, then the f point must be what? 1, 2. Can I find the derivative of f at the point 1, 2? I should be able to. Okay, what's the derivative of f? Not a trick question. What's the derivative of f? 3x squared plus 1. All right, so what would the answer be if I used the value at the point 1, 2? What am I plugging in? Okay, so that's going to equal 3 times 1 squared plus 1, which equals 4. All right, so then we can just quick finish it up. What's the value of the inverse derivative? 1/4. It's just the reciprocal. So you're going to focus most of your energy actually on the original function, but make sure you switch the point. If you forget to switch the point, then you're going to end up with the wrong number. So that means g prime of 2 is 1/4. What was g regular of 2? G regular of 2 was 1, but g prime of 2 is 1/4. Okay, we're going to try that again. There's another one. Given this kinetic function, power 5, find the inverse at 13. Okay, find the inverse at 13. All right, so set yourself up like this. F and F inverse. Interestingly, we're only given the number 13. So if I'm finding points here, where does the number 13 go? Okay. If it's right here as part of this, where does it belong? Which coordinate of which function? It's the x coordinate of the inverse function. But where else will it show up? The y coordinate of this one. So how do I find the other missing part of the pair? No, I'm not going to plug 13 in. I set it equal to 13. It is the y value of the f function. I need to find the x value of the f function. So I need to put 13 here and then figure out what math number is going to work. Okay, Sometimes you do work to solve it. You do a kinetic formula or whatever. Sometimes you subtract and set it equal to 0 to factor. But 3 and 6 and 4, those numbers should look familiar. What can you do with 3 and 6 and 4? Related to 13. They do add up to 13. Which means x has to be what number? It does. It's usually going to work out like that. They don't try and make it hard on you. Okay, so if 1 is there, where else is 1? Over here. All right. My next step is to find the derivative. So my f prime is going to be 15x to the 4th plus 18x squared. And what do I plug in to that to find the value of the regular derivative? I plug 1 in. So I get 33. So then the inverse derivative value, 1 over 33. So in other words, f inverse prime of 13 turned out to be 1 over 33. Okay, f inverse prime. All right, last one. Write a tangent line to f inverse at x is negative 4 if the function, original function, is x to the 5th plus 2x third plus x minus 4. All right. So we've got f and f inverse. Where does the negative 4 belong? Is it the x value of which of my functions? It is the x value of the inverse, which means it's the y value of the original, which means I should be able to figure out what the x value is that goes with it. So looking at the function, if this is equal to negative 4, what's the only possible value for x?
0.
Correct. Which means 0 is also the y value of the other one. Then I find my f prime, which is 5x to the 4th plus 6x squared plus 1. And so the derivative value is going to be 1 when I plug in 0. Which means the inverse derivative value is the reciprocal of that, which is also 1. Have I answered the question?
No.
Write a tangent line, which means I need to use a point and a slope. Which point and which slope? For the f inverse. Okay, I'm going to use this point and that slope. And so I have y minus 0 equals 1 times x plus 4. In other words, y equals x plus 4. And that is my tangent line to the inverse at that point.